Hey, paisanos and paisanettes. So I went fishing in the old art bin and found out a few things that didn't go out with the donation box, namely a ream of paper after I donated the inkjet printer, set of ink cartridges after I donated the inkjet printer because I was tired of buying ink cartridges every time they were expired and it wouldn't print. It's like the gift of the Magi up in here. And I found, lo and behold, it wasn't graph paper. You know, it'd be nice if it was 3D graph paper, but it's dotted paper, which is the same. It's the intersections of the graph paper without all those pesky lines. So you know, you can't draw anything straight or parallel, but we're working on that. We made some. Went to the the Anvil Vice and made some upgrades with a chisel and some stamps. You can see I got my sweet high def logo and my numbering. So you know, don't know how evenly spaced these things are since this was freehand, but you can see now if you can't read the numbers, we got every 5 millimeters and then every 10 millimeters, and the numbers are corresponding to my scale, which right now I'm assuming that these are inches. So when I do on this page over here, it tells me that this table is 36 inches. So since the last time, we've acquired some crusty, rusty sheet metal out in the garage. And I know you're going to think I've misspoken when actually I just lied to you. In the previous video, I said I was going to do 36 by 24 because that was what was conveniently available. Well, ended up I went with the original plan of 36 by 28, 28 being the widest width I could fit through the smallest door in the house. The shop or the porch door could have been like 32 wide, but you know, paranoia, if I ever move, I'm going to build a table that will last 1,000 years. I might as well be able to carry it with me. So some of these dimensions are off and everything here was perfectly to scale, so oops, I'll deal with that in a minute. However, we wanted to address the side view and more importantly, the order of assembly, how we're going to cut this to do the weldments. So I got some ideas, and I'm going to freehand first. Put the dimensions and the scale modeling aside for now. I'm going to freehand first, write in the dimensions as we go along, but just make kind of clear how I'm going to do it. So my thought is I've got this sheet that's already cut the size. This is the side view. This is my sheet of metal, not to scale. Ignore the dots entirely. Screw the lines. But it's 36 inches long, and it's a quarter thick, side view. So I'm going to have a frame. I'm going to weld a frame together underneath there. And I'm going to weld some vertical pieces. It's kind of a stack from the side. I'm going to weld an identical frame for a second sheet. So sheet, frame, sheet, frame, and I may or may not have another vertical piece. I have to look at my measurements here and how low I want the bottom shelf. And then I'll do casters. So caster, caster. And these will get bolted on, so I'm going to have a plate of some devising with bolts. So I want this as close as possible to that bottom sheet to keep everything nice and rigid. So hopefully the bottom shelf will be as low to the ground as possible and the top will be the working height. Now, again, something I said in the previous video, I said 30 inches or 30 and a half or 31 inches height off the ground. Well, for doing larger things in the forge, and this is something I had talked about, not putting sides. So optional piece up here would be sides that go around here to contain coal and stuff like that. Well, if you don't have sides, you can do a larger object easier. So if I don't have sides, for doing larger things, well, the next step that makes doing larger things easier, or laying a bar across it, or in the back of my mind, I'm thinking, well, I want to stoke the thing and crank the blower while I'm just sitting down, taking it easy sometimes, or maybe just enjoy it as a fire pit. So to make that happen, I need the height off the ground to be something less than 31 inches. 31 inches is just going to be too high to sit down. It's going to be pretty good for working with your hands standing. For heavier objects, it is going to be a few extra inches of lift. So I'm going to shoot for, I'm on the fence now, 27 or 28 inches. We'll call it 27 on account I can space these things up quite easily, but if I have to flip the thing upside down and after it's all assembled and chop the feet off or something, or if I don't have any feet and have to cut down the middle and weld it back together, that's a mess. So we're going to say 27 inches to the tabletop surface. So I'm going to go work backwards from 27 minus a quarter minus this, minus this, minus the casters, and that'll give me the length of my side pieces. Now that's an oversimplification. All of these are right angle channel. That's what I have stacked up in the garage. So now I'm going to get into the details of how exactly I think it's going to pan out, and draw how I'm going to cut the channels and where they got to overlap in places. So we're going to go one more step of detail. I'm going to go offline for a second and work on this, make it a neater version, so hopefully it makes more sense. Okay, I apologize for the high concept art here, but what you're seeing right here, let's start with this little doodad in the corner. This is my angle iron, to scale. It's 1.5 inches by 1.5 inches. It's about 3/16 of an inch thick, plus dirt and paint. So this is two sides of the frame I was talking about. So this layer that the top sheet will sit on top of and the shelf sheet will sit on top of is this guy turned on its side, run this way, that way. So there'll be another piece here that's the same as this one, another piece here that's the same as this one. Not to scale. It's relatively to scale, but not to that scale, not to a measured scale. I just used the dots and counted units off. But anyway, just to demonstrate how this is going to work. So this will have a thickness. The frame will be 1.5 inches thick, height out of the page basically. And I will cut the corners on a 45, then grind little fillets onto the chamfer, chamfer the edges off for welding purposes. So it'll actually have a gap that I will clamp. I'll clamp them where the corners will be exactly where I want it, and then fill the gap with weld. Minor detail. So this will be 28, and this will be 36 on the outside dimension. Now, I'm just going to measure the outside and cut it a 45. I'm not going to aim for any inside dimension. I'm going to use a 45-degree marker on my chop saw. Nothing fancy. No guarantees that the angles will be super precise. I will use a square and some corner clamps when I weld it together. And like I said, there'll be a little bit of slack in the joints, a little bit of inaccuracy, but probably once it's all clamped together and squared off and welded, and then I grind anything that protrudes, it'll be within probably 1/8 of an inch on the exterior dimensions, since I've done this exactly once ever. So that I was very careful and spent a lot of time fixturing and tack welding. So yeah, that's the top-down view, so you can get an idea of what these frames are. Now I've got, I looked back at the table I did before, I've got an improvement on this sketchy sketch over here, so I'm going to try to translate that into more straighter dimensionalized form. Alright, forget the outside frame that we just talked about, and I'll explain what I did here. Now, this is to a third, more different scale, also not quite to scale. So here's the same concept we talked about over here. Sheet, frame, Now, this is the trick I did before, and this takes all that stack up error and calculations out and probably is going to give you a more precise final product. And I must have been pretty smart when I figured this out the first time. So this is this profile, this angle, right angle. I mean, this is right angle, same, this is this guy is this piece. Now this is going to be this piece. It's going to overlap the top sheet, the frame, the shelf sheet, the shelf frame, and it'll overlap the plate that the casters bolt into. So it only has one purpose in life, and its purpose is to be a length 27 inches or whatever my top surface height is, minus the height of the casters itself. Now, once I weld it all together, I line it up with the top edge, weld, grind flush. I weld this guy in wherever I want him, probably at the very bottom. Like I said, I want it to be rigid, and weld from the underside or the inside so that you don't see it and I don't have to grind it. And I'll weld, because this is 1.5 inches thick, it'll be offset off the bottom of this foot 1.5 inches, and I'll weld, that's what this was, a piece of leftover 3/16 or a quarter, I think, something similar to that, same scale as the parts I'm talking about in terms of the thickness of this. I'll weld this as sort of a boxed section across the bottom into the depth of the thing from one foot to the next foot, one leg to the next leg, and it will have holes drilled in it, so I'll have a 1.5 inch gap to stick in a wrench and bolt the casters on. So the bolts will go through the caster plate, through this type of piece, welded to the bottom inside here, and I'll have a gap between it and the bottom shelf. So as long as this guy's length is correct and this is flush, then the top height will be correct. I don't have to worry about stack up, this thickness minus that thickness like I was talking about. That's the plan. So this piece, this frame is this frame. This piece is these roughly to scale bits of angle, and we're going to overlap the corners entirely and weld on. So I'll round the corners off with a flap, sander and the angle grinder, round them off a little bit so that they fit flush to the sides in here, and then do a bit of grinding on the top for welding on the top side of this one, bottom side of this one, and weld it all in there and clean it up. It came out pretty nice with my smaller cart, so this big table, the same design, should hopefully work just as well. Major disadvantage is that there is zero disassembly. Everything is welded, and it's all going to be, I'm going to guess, 100-pound cart, plus the cast iron pieces and the bolt-on forged bits and the vise, 200-pound cart. So I'm going to get some big wheeled casters that have nice locks and swivels, probably on all four corners. The locking swivels are the best kind. The rotation locks too, so that the thing doesn't do this, it's locked in place, but it gyrates. No, they can't. They have only millimeters of play instead of revolving in place. So that's the plan. Now I need to get this hardware. However, if I buy the same thing I got over there, I could go off the dimensions of it. I think I'm going to buy the actual ones before I cut this piece. Otherwise, I'd be in trouble. However, I know these guys, I want, 36, and then this, the 36, and then the 28 on the outside, and I'll use my saw guide set to a 45. So the inside length, irrelevant, as long as I get the angle very close-ish and the outside length spot on, and then do a little bit of grinding and make sure when I clamp it that everything's aligned up with the actual dimensions. Clamp it at the dimensions and weld it aligned with a square and true into the right dimension. Then it will all come out good because the weld will fill in any gaps. Obviously, if this is oversized, it's just more grinding work. So that's the plan of attack. Now you know I gotta execute it and tell you what I did wrong. Okay, and just so you can call me a liar on the end product, I'm gonna, overwrite any past dimensions I gave you. My final goal is 36 inches long, 28 inches depthways into this picture, or 28 inches on the short side of these frames, and 27 inches tabletop surface to flush ground level. That's the goal. That's what I'm shooting for, and we'll see how close I get.